Just oh geez. The sample is just a random sample that has a normal distribution, right?
Yeah.
Okay.
So this is the first question that really confused me.
Yeah.
It was like, take the input numbers you computed at number 7 of part 1. I'm like, there is no number 7 in part 1. Up to this point, I don't think, let's see.
Calculate
done any computations.
95% confidence. Show your work. T-score for this would just be like the what's that thing called you sent me, the confidence intervals.
Yeah, and so the only difference is instead of using the z-score, we use the t-score. Or instead of using the critical ratio, we use a t-score. Critical whatever.
The critical value.
Yeah.
Yeah, and then to get the t-score, that's just on the this quantitative inference procedures, the 16.117, right?
No, it's
oh no,
it's given to us right here. It says in the thing says the t-score for a 95% confidence interval from the t-distribution with 14 degrees of freedom is 2.1448.
Oh, not bad.
You
and then it's the same deal, but we do our sample size.
15.
Or is it the point estimator where that goes? Or goes in the point estimator?
Oh, I think it was the mean, right? It was the
mean of all. All right. Let me wake up a little bit. I don't want to talk about it.
Yeah. Let's see. Let me pull it up here. So you put in the mean that was given to you through the data calculation.
The 46.733.
Yeah.
Yeah.
And then the sample size is 15, and then the standard deviation is 8.27.
It's 8.827?
8.827, sorry.
Yeah, okay. You're good.
So here's what I think. I'm not sure what it's asking for in this question.
It's just asking for the upper and lower bounds.
Yeah, but and then 2 questions down it asks for that same stuff. So I just don't get it. But anyway, it also asks to make the margin of error, which I got was 4.467. I think. Hold on.
The margin of. Sorry,
no, I got that wrong. It was 4.8. We're rounding to. I don't know if we're rounding this one. I'm at 4.9 or 4.88. Nice.
Sorry, what question are you looking at?
At 8?
At 8, it asks for the.
Oh, it says with the data above, calculate the margin of error and create a 95% confidence interval.
Oh, okay.
So the margin of error I calculated is actually 4.89.
So the margin of error that got kicked out from the spreadsheet, that's not right, because I got 5.25.
What did you put in here for your critical value, your point estimate, your sample size?
2.1448. And then for the point estimate, I put 46.733. Sample size 13. Standard
sample size should be 15.
Oh, 15. Dang it. Okay, 4.88.
Okay.
And then the upper and lower bounds are 48.845, and then 51.621.
You mean 41.845?
Yeah.
Okay. So it says around to the nearest one decimal place, so it would be 41.9 for the lower bounds and 51.6. Okay. All right, cool. 9. Now we're just changing it to 99% confidence interval, and so we just changed it to the critical value to 2.9768, and that should give us a critical value of not critical. Sorry. Whatever.
Sorry, you said we changed the critical value to what?
2.9768.
2.9768. And does it, where's it provide that? Where did you get that number?
It's in the question.
Gosh dang it. I don't know why I keep I don't want to talk about it.
The last sentence is T-score 99% confidence interval.
I keep just assuming I need to calculate these numbers, so I'm like, how are you getting the numbers?
So I gotta change. I forgot to change my answers when I figured out, because I was using the critical value that we were given from our last lesson, and I put down the wrong answers.
So, okay. But for the
40.0,
for the 95, 95, it's the same thing that we just did, and then for the 99, it's
40.0 and 53.5 when rounding.
Yep. That's what I got too. Okay. Then
let's see, how does the margin of error of the 95% confidence interval compare to the 99? I said the margin of error for 95% is lower than that of the 99%, because the large margin of error for 99% is all the way up to 6.785.
Yeah. Cool. All right.
So this next one, I wasn't sure what. I guess that's more stuff like what question format is confusing to me.
Yeah.
But the null hypothesis I got was null hypothesis was u does not equal 47, and then the alternative is u does equal 47.
Yeah. And then let's see here. Then compute the test statistic. That would be that formula, right? That had sorry, I did a thing for it. Where is it? Maybe I'm gonna save it. I thought I saved it. Oh, here we go. That one's like the mean. You just test that. Sorry, let me plug it in. I've made a little thing that's like the mean divided, or mean minus the standard deviation. No, sample mean minus mean divided by the standard deviation divided by the square root of the sample, right? Something like that.
Oh yeah, that's
so the problem is what's our, oh yeah, we just went over that. The true mean is, or the sample mean is lower, so sample mean is like 46.733, and then the regular mean is 47. Standard deviation is 8.827. This is the square root of 15. That's our sample size. And I got negative 0.117.
okay. So I mean that's That's the information we're given on our
The answer sheet.
inference procedures as well. So for the t, it's negative 0.117.
Really? Mine says, or maybe it's because I updated something on it. So mine says I have, mine on the bottom one, it says T or 16.117. Did I just ignore the 16 or how's that work?
It should be computed manually, so you should have. Let's see, you should have numbers in 5 through 19 under the variable.
Yep.
And then your confidence level should be 90.95.
Yep.
Your null hypothesis should be 47.
Does it just automatically kick in to 47?
No, you have to enter that.
Oh, that's why. Okay, there we go.
And then your type of test should be not equal to.
All right, I'm an idiot. Yeah, so there we go. All right, and then yeah, our distribution for the DF is 14, and the p-value is 0.908 or 0.09, I guess.
It says to sketch the t-distribution and shade the area which represents the p-value. So p-value would just be like if you sketch the
outsides and not the middle, right?
Yeah, outside's not the middle. If you sketch the graph or the whatever, the curve. Then use the software to complete the p-value. We've used that, and yeah, it was 0.909 approximately.
Yeah.
And then state your decision. Do you reject the null hypothesis or fail to reject the 0.05 level significance? I said we failed to reject null hypothesis.
Yeah.
Because
it's not bigger than
because it is bigger than the level of significance.
It is. My bad.
Yeah, it's all right, man. It says present your conclusion in an English sentence relating to the result of context of the problem. Like, once again, the wording confused me, so I was just like, the realtor has determined that the average age of those seeking for investment properties does not equal that of a national average. Average age for those seeking average age of clients seeking for investment properties does not equal that of the national average. I didn't know what else to say because
I put just like that there wasn't enough data to prove that the mean age of people buying homes is the natural average.
And that could be true because I mean there's only 15 taken, and honestly when you put the numbers into a histogram it looks kind of right skewed, not quite so normal. I mean it's not like terribly right skewed, but it looks like slightly right skewed. But I don't know because I don't know, like failing to reject the null hypothesis, would that not in turn determine if the null hypothesis is true?
If you reject the null, then that means it's not true, right? Or there's not necessarily that's not true. There's just not enough data to support it.
If you fail to reject it, it's not enough data to support it.
Yeah. Or no, if you fail to reject it, then there's enough data to support it. But if you reject it, then there's not enough data to support it.
Okay, so we failed to reject the null hypothesis.
Yeah, so there's not enough evidence. No, there is enough evidence. Jeez Louise. Get my life together. And so it's just like, it's like the worst phrasing in the world.
Yeah, I just, like if I was to have one criticism of this section, because like I really like reading the book and watching the videos, it made sense as to how to do the calculations and whatnot.
Yeah.
But just like the wording of the questions was so confusing.
Yeah.
Like,
yeah. So if you
what it was asking for.
Yeah, if you reject to fail it, then you have evidence. If you reject it, then you don't.
Okay.
Cool.
Cool. I guess we'll do the quiz then.
I do.
Oh, man.
Okay.
Oh, there's too many questions for this short section.
Are there a lot?
Yeah. Got a T distribution applet here.
All right. Holy cow.
That's cool.
There we go.
Okay. In previous lessons, we had assumed the population standard deviation was known. In this lesson, we're making different assumptions about standard deviation. What has changed? We assume the standard deviation is unknown.
Okay. Sorry. In the previous lesson, sorry, I just got my applet up and took a minute to load. In the previous lesson, we assumed the population standard deviation was known. In this lesson, we are making an assumption about the standard.
Isn't that the standard deviation is unknown? Because that's the whole reason for this whole T stuff. Is if we don't know the standard deviation, we just define the standard deviation of the sample and use that. So the standard deviation is not the same as the mean, and we also know it's not always 1.
Yeah. All right. You're right. But it seems weird because, those two are clearly not right, but it's pretty easy to. I guess it's unknown. They're not just giving it to us, but it's pretty easy to find. You know what I mean?
Yeah. Well, the other thing is before we had a standard deviation of the actual population. Yeah. And now we only have the standard deviation of the sample. So I guess the only difference, I guess. For the next two questions, let the null and alternative hypothesis be U doesn't equals 8. And U is greater than 8. Assume that the population standard deviation is not known. Becca collects a sample size of 9 and computes x bar equals 11, and the sample standard deviation equals 6. Is standard deviation known? No.
So that one, is it known? I mean, it says that it's not known, but we can find it. Is it asking if we can find it, or is it asking if it's not given?
Well, so it's the symbol right there is the population standard deviation.
Yeah.
And so it's not known. But and really we can't find the population standard deviation because we can't sample every single thing in the population, unless we can in this situation. But so all we have is a sample standard deviation. So I guess I'm taking this question as the population standard deviation is not known. Okay. Because if it were asking if there was a sample standard deviation, it'd be S.
I thought the sigma was the sample, or was the sample deviation. What is the sign for this sample deviation?
It's just S.
Oh, okay.
If I recall correctly, that's what it was.
No, you're right. I'm sorry. Let me get my life together.
Okay. What is the value of T? Rounded 1 decimal point. Okay.
Oh, I got that.
Let's do a test.
So
let's throw everything in the test statistic formula.
Yeah. So so they're saying the mean is 8. The sample mean was 11, right?
Yeah.
8.
Then the standard deviation would be 6. Then the sample size is 9.
Yeah. Square root. I need to put this in my formula better. Square root. So I'll have to adjust it every time. Oh, yep. I got 1.5. So what you got?
1.5. I'm trying to find. I lost, so I don't have that file. So I'm trying to make it again.
I just put it on I can send it to you if you want.
I can.
It's a pretty quick one.
Yeah, I can make it. It'll be fine. We can just move on for now. I'll trust you. 1.5.
1.5. Let me just double check I did my numbers right. Sample mean 11, mean 8, standard deviation 6, and then the square root of 9.
Yeah.
Okay. Cool. 1.5.
Right. So what is the value of t? Oh, sorry. Next question. Use the following values, paste them into your software. Use null hypothesis of u equals 98.6. Oh gosh. The alternative hypothesis to use less than 98.6 and level of significance is 0.05. So let's enter this stuff in. Okay, that's cool.
Yeah. I hate that you can't copy and paste. Hey, we're gonna give you a crap ton of data, but we're not gonna let you copy it.
Yeah, right. Okay, I'd delete this data. Okay, 98, 6, 0.8. Okay, and what was the information here? 98.6.
All right. Null hypothesis equal to 96. Is that what it's saying?
98.6.
98.6. Oh, we're doing temperatures. 98.6. And we're not doing we're doing that it's not equal to or that it's greater, right?
It's less than.
Less than. Crocodile's mouth hits the lip.
Okay, so what is x bar round to 3 decimals? So I got 98.220.
98.220. Where
Variable 1 mean?
98.22. Yeah, there we go. Sorry, man.
You can. What is S? So sample standard deviation. I got 0.922.
S, yeah, 0.922.
What is a t-score?
Negative 1.843.
That's what I got.
.040.
The p-value.
No, it would be 0.1, right?
Say what?
0.041. Sorry.
Yeah.
P-value?
Yeah. Sorry. Yeah, I was a little confused.
No, you're all right.
Save. What is the correct decision based on this evidence? I think we reject the whole null hypothesis because the p-value is less than
5.
The confidence interval, or the 0.05. Yeah.
The significance level.
Yeah.
Okay.
More data.
Oh, wait, what was the significant level?
The what? It was 0.05.
Okay, cool. Oh, geez. Okay.
If you use the following values, which are pulled from a data from Baby Boom. Next 6 questions.
It's not equal to 40. Stupid information again.
40. Oh gosh. 40. Oh, not equal to. And start entering data again.
Did you get 21 variables?
I'm still typing.
Oh, sorry, man.
Yeah.
Oh, dude, are you taking 321? Business
Do
320?
No, I'm in business 183, and then I have religion class. How many variables did you say?
21? I got 21.
Is that 5 through 25?
You 25?
Is it 5 through 25 in the spreadsheet?
Oh. Yeah.
Okay.
Starting with 59, ending with 61?
Yeah. And confidence level is still 0.95. Null hypothesis was 40, and the not equal to. Yeah. Okay.
My p-value was 0.995.
Yeah. We failed to reject null hypothesis. Yeah.
Yeah, because it's bigger than the 0.01, right?
0.05. But yeah.
Well, it was the significant level this time was 0.01.
Well, it should be 0.05 if we're doing a confidence level of 95. Oh, so we should be confidence level of 0.99 then.
9 minus 3
doesn't change anything, but yeah.
Or no, so we're good though. We're failing to reject it, right?
Yeah. Still, either way, we'd be failing to reject it. But yeah.
Okay.
All right. You decided to try another alternative hypothesis. This time, use U is less than 40, so do less there. Okay, come on.
Jumped up to 5.
Went down to point. So.
Point increased.
Keep the same level. So did the p-value increase or decrease?
It decreased. I lied. I thought it was 4 or something for some reason. Decreased.
What decision did you make? We still reject this one. We still fail to reject null hypothesis. Right?
Yeah, because it's still bigger than 0.01.
Yeah. Okay. And now construct a 95% confidence interval for a true mean wait time between births at the hospital. So.
Was that the information we were using? Birth into the hospital? Okay. I should read these better. So 95% confidence interval. So did you get the 23.5?
499?
Yeah, but
that's what I said. 23.5, yeah. And then
26.
Yeah. Okay, I'll go ahead and submit it and see how that went. This is the first one where I've been like, I don't know, guys.
Yeah.
I mean, I guess Guy, because Andrew's not here.
No.
We got 100%. Cool.
Cool beans.
We did it right. Congratulations.
I like that they provide us with this spreadsheet already set up because yeah, we could do it, but
the fact that time, you know what I mean?
Yeah, exactly. I think it's way cool. To me, it feels like they're like, hey, I know you got a lot going on. Here's this. This will help you out. You know?
Yeah, because I mean, we not to complain or anything, but I mean, we could have 3 or 4. Some people have 5, 6 classes, and creating spreadsheets would be a lot of busy work. Sad we didn't use this actual T-score thing. I like that. the applet, but
yeah, I have this lady in one of my other classes. We have to meet in groups every every day or whatever, or every week, and she's only two classes, and she's like a stay-at-home mom, and she is always like super like gung ho and wants to like go everything super in depth. And I'm like, dude, I got 5 other classes I got to get stuff done for today. Let's wrap this up.
Yeah, right.
Like we've done what we need to do to get an A.
Yeah.
But,
and there's the thing, like, that's all it's about, man.
Yeah, just
like, learning and then just get a good grade so you can graduate and move into the workforce where you'll apply like only
a fraction of what we're going over.
Yeah, not even 50% of what you learn.
Yeah.
Because, then you get into stuff that's like more
specialized,
like, Java specific stuff that you wouldn't do anywhere else.
Yeah.
Like, I mean, like where I'm going to work, they're just like, sure, a business administration degree would be good, but I would literally use about 5% of what I'm learning in the statistics class, maybe, if I'm lucky, in a management position there.
And now I was looking at like internships for moving to Boise, so I'm like looking at internships to do with like Micron or something, and like a lot of the descriptions I'm like reading, and none of them I'm like, I could have done this internship or got this job without having this degree.
Yeah.
You know what I mean?
Yeah. There's a lot of stuff, a lot of those like that. But I mean, a degree always helps because it gives you a lot more variety, of options.
Yeah, for sure. But,
all right, dude. Hey, this is fun. I'm gonna go back to bed. So you have a great day.
You see you later, man.
Yeah.